Before we get into actual section 3 stuff, I wanted to review the two methods that we know at this point. We know the graphing way of solving a system of equations, and we know the substitution way of solving systems of equations. So we're using this system right here, and we want to graph this thing. In order to graph it, we have two options. One option would be to put everything in slope-intercept form and graph it that way. That's usually the stronger option. The other option would be to graph using intercepts, since these are written in standard form, sort of. The problem with using intercepts is if your intercepts are very, very close together, like if I had intercepts that were here and here, my two dots for my line that I'm going to draw are very close together. So if I'm off by a little bit with my ruler, that could really screw up my answer for my ordered pair when I go to graph it. So I don't want to use intercepts on this one because I don't have exact, like this one looks good, the x-intercept here is just 1, but the y-intercept here is -1/2. And if I have 1 here and -1/2 here, like I said, that's going to be kind of tough to get an accurate line. With this one, the x-intercept is 8, that's nice. The y-intercept is something in a fraction form, 32/6. So that would be 16/3. So we're going to have to try to figure out what 16/3 is when we go to graph it. It's not too big of a deal. But I want to put these in slope-intercept form. So that top equation, the first thing I'm going to have to do is subtract the 4x from both sides. This is just good practice here. So minus 4x from both sides. And now I have 6y equals -4x plus 32. Now I divide everything by 6. And I get y equals -2/3 x plus that 16/3 that I said earlier. So that one's in slope-intercept form now. How about the other one? How do we put that one in slope-intercept form? Been doing it all year. That's a positive 3x, and I want it to disappear, which means I need to subtract 3x. It's the sign of the term, not the sign that you see after it. That's why you made that mistake. So that's a positive 3x. We need to subtract 3x to get it to go away, to get it to turn into 0. So 3x minus 3x is 0. Now I have -6y equals -3x plus 3. Divide everything by -6. What do we get? Plus -1/2 can be written as -1/2. Okay, so now both of our equations are in slope-intercept form, and that's going to make it easier to graph. The hardest part about this blue one is going to be that y-intercept of 16/3. How do I get to 16/3? Yeah, you could turn it into 5 1/3. 5 1/3 is going to be 1, 2, 3, 4, here's 5, and then 1/3 of the way up. And I got to kind of guess, but it seems like maybe right about there. If this will let me draw a dot. So that looks like my y-intercept there. Now, if I put a bunch of dots in here, then if I'm off by a little bit right here, it won't matter as much. So I'm going to use my slope now of -2/3. From here, go down to 1, 2, and then right 3. 1, 2, 3. Put my dot. And then continue doing that. And if I do that over and over, and I get my dots nice and far apart, then any little mistake that I have along the way is going to kind of be reduced to where it doesn't really matter. So down 2 again, and then right 3 again. Down 2 again. So 1, 2, and then right 3. Down 2 again, 1, 2, right 3. Maybe I can go the other way. Up 2, so from here, 1, 2, left 3. Up 2, 1, 2, left 3. Okay, so that seems like it's probably enough dots. Go ahead and draw on my line as accurately as I can. Down, 1, 2, left. Oh, I didn't go over far enough. There we go. And there's my line. Now the other equation is going to be slightly easier. We have a y-intercept of -1/2. which is there. And then a slope of positive 1/2. So I go up 1, right 2. Up 1, right 2. Up 1, right 2. Over and over. Now I've crossed my line, so I know that I have a solution somewhere in this region right here. So I'll draw this line in here, and then where does it look like my two lines cross? They sure do look like they cross at 5,2. So I'm going to guess that the answer is 5,2. How would I know for sure if the answer was 5,2? Yeah, you want to plug those in and check. So I'm guessing 5, 2. That's the best I can do here because my dots didn't actually land on top of each other. So I don't know for sure, but it sure does look like 5,2 to me. So I'm going to try 5,2 and see if it actually does work. So for my red equation, I'll plug in 2 for y equals 1/2 times 5 minus 1/2. 2 equals 5/2 minus 1/2, which gives me how many halves? 4 halves, which is 2. So it actually did work. 5, 2 did work for that one. Let's try it for the blue one now. 2 equals negative 2/3 times 5 plus 16/3. What is negative 2/3 times 5? 2 equals negative 10/3, that's right, plus 16/3. And when I put those together, what do I get? 6/3, which reduces down to 2. So this one also worked, which means 5, 2 actually is the correct answer, even though I had to guess for my graph. So if you haven't noticed, I've said like 3 or 4 times that we had to guess from that graph using the graphing way of solving this system of equations. And that's the best we could do with graphing. So with graphing, you have to be very careful. And the best you can do usually is guess, unless your dots exactly land directly on top of each other, which is not what happened in this case. All right, so that was the graphing method. Now we're going to jump into section 3, solving systems using what we call elimination. But before we get into elimination, I want to do this system over again. This is what we just did with our graphs. I want to do this system again, but with substitution this time. So the question is, how do I do substitution with this system of equations right here? How do we get started? Well, it doesn't have to be slope-intercept form. What do we need to do actually? Solve for one of the variables. It doesn't matter which one. It could be x or y. It could be the top equation or the bottom equation. Is there one that looks like it's going to be the easiest to solve for here? Normally we look for a variable that's just like 1x or 1y. Do we have that here? No. So we're going to have to find one that looks like it's going to be the easiest and then go with it. The bottom one, and which variable, x or y? X? Definitely. Here's why. If I solve for this x right here, then that means that this y has to move over, and I'm going to have to divide by 4. Well, 32 divides by 4 nicely, but 6 does not. So I'm going to wind up with a fraction. I don't like that, so I'm going to try something else. If I solve for this y, then I'm going to have to move the 4 over. 32 does not divide by 6, so I get a fraction. 4 does not divide by 6, so I get a fraction. This y is terrible to solve for. If I solve for this y, then this x is going to have to move over, and I'm going to have to divide everything by 6, and I'm going to wind up with fractions. But if I solve for this x right here, then this y is going to have to move over here, and I'll divide everything by 3. 3 divided by 3 is not a fraction. 6 divided by 3 is also not a fraction. So that's why this x right here is the best one to solve for. Thinking ahead a little bit, and instead of just plowing into the problem and then coming up with fractions, stop and think about which one you want to actually solve for, and a lot of times that's going to save you time, even though you spent 10 or 20 seconds thinking about which one to solve for. It saves time. So we're going to solve the bottom equation for this x right here, which means what do I need to do? Yes, we need to add 6y to both sides. So I'm left with 3x equals 6y plus 3. Now what? Divide everything by 3. And we get x equals what? 2y. Good, plus 1. Now what? That's right. We know what x is now. So I'm going to take what x is and substitute it back in up here. Which equation do I need to use? I have to use the top one because I took the bottom one to make this. So this guy has to go here into the top equation for x. So what do I write? Good. All right, so we did the substitution. Now what happens? Distribute. So we get equals 32. Good. And then what do we do? Yeah, always combine like terms after you distribute. So we have an 8y and a 6y, which combines to give me, yep, 14y. Keep going. Plus 4 equals 32. Subtract 4. (32 minus 4). 28. And then divide both sides by just 14, and you get y equals 2. Nice. So we got y equals 2. Now what do we do? Take this back over here into something. The bottom one? You mean this one right here? Yeah? Good. So we'll use the bottom equation though. Okay. So we're going to write 3x minus what? Plus 3. Okay, what happens now? This is the bottom equation, so we're going to write 3x minus, this is equals 3, sorry. 12. Okay, solving for x. Add 12. 15. Divide by 3 and we get x equals 5. Okay, so now we know what x and y have to be, so what do? Make the ordered pair, right? So I'm going to write 5, comma 2. Exactly the same system of equations that we had on that graphing problem that we just did. This time we used substitution, and we got this as our answer. Exactly the same answer. Which way was better? The substitution method, definitely. Because in the substitution method, we didn't have any fractions anywhere, and we didn't have to guess in the answer in the end, because substitution gets us to the answer much more correctly than graphing does. So the method we're going to learn in this section is called the elimination method. It's a third way of solving a system of equations. I think you're going to like it. Sometimes substitution isn't the easiest way to solve a system of equations. Sometimes this method that we're dealing with today is the easiest way. So take another look. This is the same exact system of equations once again. But we're going to use elimination on it this time, so you can see how elimination kind of pays off. So what would happen if we added these two equations together? Just like if I had like 54 plus 22, and I drew a line, and I added the two equations together. Well, I have 4x plus 3x, which gives me what? 7x. Then I have this 6y and this negative 6y. If I add those two, what do I get? What's negative 6 plus 6? 0. So I get 0y. What is 0 times y? 0. So these guys add and they disappear. The equal sign is still the equal sign. And what's 32 plus 3? 35. So by adding those two equations, the y variable actually disappeared. And now I'm just left with 7x equals 35. Well, I can solve that. How do I solve for x here? Divide both sides by 7, and I get x equals what? 5. Isn't that what we've been getting for the graphing and for the substitution? We got 5 again. So now that I know what x is, how could I figure out what y is? Yeah, I know what x is, so I can plug it back. So I can take the 5 and substitute it back in up here. You can't really get away from substitution completely, but we can do elimination to help us get to the answer a lot faster in this case. I can plug that back into either one of these two equations, whichever one looks easier, but I have to go back to one of these two. So which one do you want to pick? The bottom one? The numbers are a little bit easier looking, so sure, let's plug it into the bottom one. So I have 3 times x, which is 5, minus 6y equals 3. And now just solve for y. So 3 times 5 is 15, minus 6y equals 3. Then we're going to subtract 15 from both sides because that's a positive 15 sitting there. And I'm left with negative 6y equals, what's 3 minus 15? Negative 12, good. And then I divide both sides by negative 6, and I get y equals what? Positive 2. So, I didn't need to circle this x over here. Probably shouldn't have. Because my answer is not x equals 5. It's not y equals 2. What is it? 5 comma 2 written as an ordered pair. That's my answer. And now we've done the same system of equations 3 different ways. Graphing, substitution, and now your first crack at elimination. So out of those 3 methods, which one looks to be the easiest for this system? For sure, elimination. Because we got down to just x equals, and in 2 steps, 2 moves later, we had what x was. And then substitute it back in and you get y very easily. So the y variable disappeared. We have eliminated it. That's why it's called the elimination method. Now it's easy to solve for x. Just solve for x and then substitute. You still have to substitute in the end. You can't get away from it completely. But you substitute that value back into one of the original, this is very important, original equations to get y. You'll see why that's important by the end of the section. We have a couple more practice problems here. Let's take a look at that first one. If I add those 2 equations together, what happens? Yeah, so what happened? The y's will disappear when I add these 2 together. How do I know that? Because I have a negative and a positive, and also the same number on those variables. Okay, that's going to be important in a little bit. So we are going to be able to add these 2 equations together right now and eliminate the y. What do I get? And then 17 minus 9 is not 2. It's 8. That's 17 plus negative 9, basically. 17 minus 9 is 8. Okay, solve for x. What do we do? Divide both sides by 8, and we get x equals 1. Now what? Substitute it back into one of the 2. Which one looks easier? The top one? Okay. So we'll go to the top one. 2 times 1 plus 5y equals, just finish off the equation. Now what? Yep, just keep solving. 2 times 1 is 2 plus 5y equals 17. Then what? We're going to subtract 2 from both sides. 5y equals 15. Divide both sides by 5 and you get y equals 3. So your ordered pair is 1 comma 3. And what should we do? Before I put a box around it, plug it in and check. These problems are easy to check. I take a 1 and I plug it in for x. I take the 3 and I plug it in for y. 2 times 1 is 2. 3 times 5 is 15. 2 plus 15 is 17, so it works. I don't know how long that took, but it wasn't very long. This will be 6 minus 15. 6 minus 15 is negative 9. It's not like I got to write anything down. I can check it in my head, but check your work to make sure you're doing it correctly, especially when you first start off on these. How about this second problem? Let's go ahead and do that one. Try it out on your own, and we'll come back and talk about it. If I add these two equations together right now, what happens? X disappears. So that means I can add them together. Negative 3x plus 3x is gone. 0. Negative 3y plus negative 4y is negative 7y equals 14. That's awesome. Solve for y. Divide by negative 7, we get y equals, good, y is negative 2. Now what? Substitute back in somewhere. Which one do you want to use? The top one? Sure. Either one is fine. So I'm going to write what? Negative 3x. Good. Look at all those negative signs. Be careful. So what do I get now? Good. Plus 6. Okay. So now what? Yep. Okay. X equals negative 1. Now what? Right? Order pair is? Okay. And what should we do? Check. Hopefully it's right. Negative 1 goes in for x, negative 2 goes in for y. So this turns into what? Positive 3. And then negative 2 times negative 3 is positive 6. So we have 3 plus 6, which is 9. Sweet. And then we have, what's this? Negative 3. And then what's this one turn into? Plus 8. Is that 5? Yes. So now that I've checked it, I know it's right. I can put my box around it and move on. It's a good skill. Next, take a look at this. Let's ignore the words here for a minute. Take a look at this system right here. If I add those two equations together right now, will a variable disappear? No, it won't. If I add the negative 5x and the 3x, I get negative 2x. If I add 6y and 6y, they don't disappear. Even though the numbers are the same, they don't disappear. You get 12y. The whole point of the elimination method is to get something to disappear. So we have a problem here. We can't use the elimination method right now. And that's where the words up here come into play. You always want to make opposites in your equations and add them together. I will not teach you any other way. You make opposites and you add them. Okay? What does opposites mean? Opposite signs, yeah. So if I had a positive 6y and a negative 6y, then I could add those equations together and they'd disappear. Or if this was a negative 6y and this was a positive 6y, then I could still add those two equations together and they would disappear. So if you have the same number and the same sign in front of a variable like we have right now, just multiply one equation by negative 1. It doesn't matter which one. Just pick one, but only one. And then you can add the two equations together. Okay? So what I want to do is multiply one of these two equations by negative 1. And that will change all the signs in that equation and give me opposites in y. So to do that, what I'm going to do is this. I'll just pick the bottom one. It doesn't matter which one. I'll just pick the bottom one. And I'm going to multiply it times negative 1. You see how I kind of made a distributive property looking problem there? Then I'm going to draw a little arrow over, and I'm going to rewrite that system of equations. I didn't do anything to that top equation, so I'm just going to rewrite it as is. Negative 5x plus 6y equals 32. But I did multiply the bottom equation by -1 to change all the signs. So I distribute the -1 into each one of those three terms. -1 times 3x is -3x. -1 times positive 6y is -6y. And then I also have to do across the equal sign because the whole equation has to get multiplied by -1. -1 times 48 is equals -48. Now do I have opposites so that when I add, something disappears? Yes. So now I can draw my line and add these two equations together. So I have -5x plus -3x. What is that? -8x. Good. And then positive 6y plus -6y gives me 0. It's gone. Equal sign comes down. And then I have 32 plus -48. Yeah, that's -16. Okay, so I eliminated y, and now we're right back to where we've been. So what do we do now? Divide both sides by -8, that's right. And we get x equals positive 2. Now what? Now we substitute the 2 back in. Now it has to go back to an original equation. We're not going to use these over here. We're not going to do anything except for use one of these two original equations. So pick one of the originals that looks easiest. The top one? Okay. So then I'm going to write -5, using the top equation, times 2 plus 6y equals 32. And then I have -10 plus 6y equals 32. Now what? Yeah, we're going to add 10 to both sides. And we have what? 6y equals 42. So now we divide both sides by 6. And what's 42 divided by 6? 7. Oh, now what? Write your ordered pair, which is 2 comma 7, and check. X is 2, y is 7, so 2 comma 7. All right, take and substitute these in to both equations, because one equation is automatically going to work. The other one might not, though, if we made a mistake. So -5 times 2, -10, and then 6 times 7, 42. -10 plus 42? That is 32, so that one worked. Now we need the original equation here, not when we multiplied it by -1. So we have 3 times 2, which is 6, and then 6 times 7, which is 42. So 6 plus 42, is that 48? Yes. So because we checked it and it works, we know that that's the correct answer. No other ordered pair works. So you have to check, and you need to check both equations, because one will work. The other one might not if you made a mistake. All right, again, let's try that second one on our own here, and then we'll come back in a little bit and talk about it. Give it a shot. You want to make opposites. Draw a line on here so we don't get confused. Okay. What do we need to do here? Yeah, make some opposites. We don't have opposites. The -4y and the -4y will not disappear if we add. So, we need to do what? Yeah, multiply either equation by -1. We'll choose the bottom one, that's fine. Draw a little arrow over and rewrite the system. Did I do anything to my top equation? No, so I just rewrite it. -3x minus 4y equals -22. And the bottom equation becomes -38. Okay, now do we have opposites? Yeah. So we can draw our line and add. And if we add, what do we get? Don't forget the x, -8x. That's -60. All right, now what? Divide both sides by the negative 8. And we get x equals positive, because it's a negative divided by a negative. And then 60 over 8 reduces to 15 halves. Stick with the fraction. Don't go to decimal. It's going to be easier. 15 halves. We got a fraction. It's not that terrible. It's not bad. Keep going. Take the 15 halves and do what? Substitute it back into one of these two equations, one of the originals. Which one do you want to pick? The top one, okay. So we're going to have negative 3 times 15 halves minus 4y equals negative 22. All right, so what is this becoming? Negative 45 halves minus 4y equals negative 22. Now what? This is a negative 45 halves, so we're actually going to add 45 halves to both sides. And what do we get? Negative 4y equals, and now negative 22 plus 45 halves. You have a calculator in front of you. What do you get? 1/2. If I were to convert this, this would be negative 44 halves plus 45 halves, which gives me positive 1/2. Get comfortable with fractions. You can actually do that math faster in your head than you can typing it into a calculator if you get comfortable with fractions. So let your brain do that. Negative 4y equals 1/2, so what do I need to do? Yeah, I could divide by negative 4, or I could multiply both sides by negative 1/4. Either way, I get y equals what? Stick with fractions. That's negative 1/8. So my answer, ugly as it is 15 halves, comma, negative 1/8. Now what? Check it. You don't want to, do you? You have a calculator in front of you, though. The calculator will check this for you. You type in negative 3 times 15 halves minus 4 times negative 1/8. Press enter. Do you get negative 22? I'll give you a hint. The answer is yes. And then if I plug in 15 halves here, 5 times 15 halves minus 4 times negative 1/8. Press enter. Do you get 38? The answer is yes, because this is the correct answer right here.